All right. Good evening, everybody. My name is Nick Smith. I am a senior engineer at Southern Company down here in Birmingham, Alabama, and I'm also a student at NC State working on my master's in nuclear engineering, and I'm presenting to you today for an opportunity to invest in an advanced nuclear reactor technology. A little background on Southern Company. We were founded in 1912. We've got over 4 million customers, about 46 gigawatts of generating capacity, 26,000 employees, and last year our net income was right around $2 billion. So we're building 2 nuclear reactors right now, actually, in Augusta, Georgia. They're AP1000 technology, Westinghouse design, and the project is those reactors should be coming online in the next couple of years. So the nuclear industry is really interesting. We built a lot of reactors back in the 60s and 70s, but we have not continued to build them over the last few decades. And those machines have a finite lifespan. They're going to be retiring coming up here soon. We don't really have a great strategy to replace them all. There's a tremendous amount of generating capacity that's going to have to be replaced between 2035 and 2045. I got into advanced nuclear 2-3 years ago and have been working with a company called TerraPower, who has a nuclear reactor design it's radically different than anything we're currently doing. It's actually based on a liquid fuel molten salt in the fast spectrum. So if you can imagine a cup of table salt, if you heat that salt up enough, it becomes a liquid, and you can actually powder up uranium and drop it into that salt, and it'll stir in, mix up, just like sugar would mix into sweet tea. That gives you some really interesting safety features. It helps your economics because you're no longer having to manufacture fuel. The machine operates at atmospheric pressure, so you don't have to have huge pressure forgings that can only be made on like 2 places on the planet. And it gives you a sustainable fuel cycle. This machine is actually capable of burning spent nuclear fuel from our existing nuclear power plants. TerraPower's team, they were formed in 2008 by Bill Gates, and he basically said, go hire the best talent you can possibly get, get them from academia, national labs, industry, and put together the team that's going to build the nuclear reactor of the future. So they're pretty much the 1995 Chicago Bulls of nuclear energy. They've got some amazing folks there. Now this technology is a really interesting investment opportunity for Southern Company because there's a lot of ways to monetize it. We can be expert operators down here in the southeast, and because the generation, the source of the energy is so cheap, it helps us support our customer base and protect our existing business model. It's also something that we could get involved a little bit more aggressively in and maybe become an IP owner or take a equity share in the company, and that could be a major payoff for us. The technology's got a lot of interesting features. It's a high temperature reactor as compared to like a current light water reactor. So it operates at about 750 degrees Celsius, which lets you get a more efficient thermal conversion to energy. It's also a low pressure system, so there's no pressure built up inside the machine. You can take the top off of it and it wouldn't explode or anything like that. It just kind of would sit there and you could look at it. You can refuel this machine online, so you don't have to take an outage to add more fuel. It's got a sustainable fuel cycle. It's capable of burning spent nuclear fuel, and it doesn't create additional waste that's got a long radioactive half-life. Extremely high power density in this machine, which means it's going to have a small footprint. You need less steel and concrete to build this machine. And it's also possible to cool this machine with natural convection. That salt, it will heat up, and when it gets hot, it expands, and so it'll kind of flow in a natural thermosiphon effect. And basically, with any kind of passive cooling, you could walk away from this machine, and it's the most safe design you can possibly imagine. We did $1 million costing study over the last year looking at this design in detail, trying to figure out exactly what it would take to build one, and came back with a Class 5 cost estimate, which means it's minus 20% to maybe double the cost that we think it is right now. We plugged that into our production cost modeling software here at Southern, and it is a major winner. In all different natural gas, load growth, CO2 tax scenarios, this machine is cheaper than the next possible generating source. So it's got a really great potential for our company. did a SWOT analysis on TerraPower. Their strengths include the fact that they've got great intellectual property, they have incredible talent, and they've got a strong political presence. Having Bill Gates on your team is not a bad thing. Weaknesses, they've got a 15 to 20 year development timeline ahead of them. It's a long time before they're going to have a product to sell, and it's expensive to get there. In addition to that, they've got regulatory risk because the NRC currently has no way to license this machine. It's not a light water reactor, and so there's no framework to actually push this through the NRC. And then there's always technology risk with new products. The opportunities, though, are just outstanding. I mean, in 2013, we spent $1.6 trillion on energy supply, and that number is expected to go up in the future. This machine can also consume nuclear waste. There's no other design that's really targeting that market right now. And because the fuel is liquid, you can do chemical processing to separate out medical isotopes. Some of these are used to treat cancer, to do medical imaging. It's a whole new market for us. Threats, they've got a lack of a licensing pathway currently. There's the potential that over the next 20 years a better generating technology comes along, and the fact that they need so much funding. I mean, you're looking at about $3 billion to get you to a final design. Also did a Porter's 5 forces analysis on just the nuclear industry. Right now, the threat of new entrants it's actually pretty low. There's a high barrier to entry. It takes a lot of financing and a lot of people to make a nuclear reactor. Currently, the bargaining power is in the buyer's favor. But once TerraPower, for example, gets a reactor built and people see that it is safe and economical, that's going to flip, and that's actually going to be, they're going to have the upper hand in terms of bargaining power. Threat of substitute products, there's always natural gas and renewables, so the product can't be overly expensive. And there are other technology vendors that are pursuing advanced reactor designs. Currently, nothing as interesting or exciting as the TerraPower design. So earlier this year, the group I work for was selected for a $40 million DOE award to pursue this technology. Southern Company was the lead on this. We were the principal investigator. TerraPower is the technology designer. Oak Ridge is helping us in terms of technical support and testing, and EPRI is helping us with operations and maintenance. So the goal of this project is to answer some key technical questions related to corrosion and chemical solubility early, and then build a 2 megawatt electrically heated reactor that demonstrates all the physical phenomena but with no radiation or fission events. We're going to take all that data and all that learning and send in an application to the NRC for a 30 megawatt test reactor. And this will be a real nuclear reactor. It'll be about the size of a trash can, so it's not very big, but it will need a nuclear reactor license to operate. Over the next 20 years here, you can see we're going to go for the 2 megawatt integrated effects test, so that's the electrically heated machine. Then we're going to build the 30 megawatt test reactor, and then finally in the mid-2020s, early 2030s, we expect to have a prototype plant online that would be kind of the first of a kind. And that should be around the mid-2030s that we think we can get to that. This reactor is clean. It has no emissions. It minimizes waste. It can actually consume spent waste. It's safe. It's completely self-regulating. The salt expands when it gets hot and actually turns the nuclear reactivity down. It operates at atmospheric pressure, so there's no potential for it to explode or contaminate the public. I mean, we spent a lot of time thinking about this, and realistically, the only way you could expose the public to radiation from this machine is if you detonated some dynamite in the middle of it or something like that. It's reliable. The design is extremely simple. It's elegant, and this should give us an improved quality of service for our customers. And most importantly, it's affordable. Because of the high power density, you have a smaller footprint, doesn't take as much steel and concrete. Low pressure means you don't have to have big, thick steel forgings. You can just, have smaller materials needs. And it's also got very inexpensive fuel because you're not manufacturing fuel rods. You're making salt and powdering uranium and dropping that in there. This is a huge opportunity for Southern Company. We need to invest aggressively right now because advanced nuclear must be the anchor for an all-of-the-above energy strategy. Thank you so much for listening. I really appreciate your time.